Okay, in section 2.8, I know we're a little out of order here, but I think this is a good time to do this section. In 2.8, we're talking about inverse functions. Okay. So inverse functions are functions that undo each other, or you could think about like they cancel each other out. Okay, so if we have a situation like that, then we call those two functions inverses of each other. Okay, so we'll say this, we'll say inverse functions and then we'll say they undo each other. Okay, so that's not a very technical definition, but it gets the point across. Or you could say they cancel each other out. Okay, and we use inverse functions when we solve equations. There's nothing new about that. So we say, well, if we're adding 3, that we want to cancel that out, we subtract 3. Or we've got x squared, and we want to undo that, so we take the square root. Okay, so those are inverse operations. Okay, here we're talking about inverse functions. So one thing you can think about with inverse functions is inverse functions switch the inputs and outputs, or the x's and y's. Okay, so if we have a function, and we have a point on the function, so if we have the point 3, 2, and that's a point on the graph of f, okay, well, remember with our function here that this is x comma y. Then if we have the inverse of f, and the way we got the inverse of f is f with a -1 looks like it's up in the exponent. Okay, so that means f inverse, the inverse function of f. Then we know automatically, if we know a point on the graph of f, then we know a point on the graph of f inverse. Because to get f inverse, we're just going to switch x and y. So if f has the point 3, 2 on it, then on f inverse, we're going to have the point 2, 3. We just switch x and y. So anytime you have a point on one, you can figure out a point on the other one just by switching x and y. Okay. Another way of writing the same idea, okay, is we could say if f of 5 equals 1, then remember this is our input, so this is x, and this is y, our output. Then we know f inverse of 1, what's that going to be? That has to be 5, right? They're just backward, they're switched. They're switched there. I'll not say a little typo I made here, this is supposed to say then. So if f of 5 equals 1, then f inverse of 1 equals 5. Okay, we're just switching x and y around. Okay. If not all functions have inverses, but if a function has an inverse, if it does have one, okay, we call that function, got terminology that we use here, and the name we give to it is 1-to-1. Or sometimes you'll see it like this, you'll see it with numbers, so you'll see 1-to-1, like a ratio. Okay, so if you see that the function is 1 to 1, one thing that tells you is that that function has an inverse. Okay. And for us, the easiest way that we can check to see if a function is 1 to 1 is by looking at its graph. Okay, so if we're looking at the graph of a function, we can do what we call the horizontal line test. And so this is just like the vertical line test we did to test if a graph was a function. But here we're testing to see if a graph is 1 to 1, or if a function is 1 to 1. So our horizontal line test says if any horizontal line that's a line going left to right, any horizontal line touches the graph of a function more than once, then the function is not 1 to 1. And that means it does not have an inverse. Okay, so in other words, if we think about the other way around, if there's nowhere that we can draw a horizontal line that touches the graph more than once, then the function is going to be 1 to 1, so it does have an inverse. Okay, so let's look at a couple of graphs here. So here's a function, okay? And we look to see if there's anywhere we can draw a horizontal line that touches the graph more than once. Okay, on this one, there's not. Okay, so this function is 1 to 1. That means it has an inverse. Okay. Let's look at another function. So what about this one? Something that looks like x squared. And put my arrows on the other one. Okay, so here, what about this one? Well, if we draw a horizontal line in right here, or a bunch of other places we could have chosen, but for sure if we draw in one right here, it's going to touch our graph more than once. So this one is not 1 to 1. Okay. That means this function has no inverse. Okay, so several of the problems in the homework just get you to look at the graph and do the horizontal line test. Okay. All right, and then the last thing in this section we want to talk about is we want to talk about how to find an inverse function. So we want to find a formula. Okay. So I'm going to give you some steps here, okay? And if you kind of do it this methodical way, it helps keep it from being so confusing. Okay, so you're going to be given f of x equals something. Okay, step number 1 is we're going to change our notation f of x to a y. Okay, that just keeps us from having to deal with that f of x notation the whole time. Okay. Step 2, okay, we're going to switch in our equation the x's and y's. Okay, so wherever there's an x, we put a y. Wherever there's a y, we put an x. Step 3, we're going to solve for y. And when we do that, y equals our inverse after we solve for y. Okay, so change f of x to y, switch the x's and y's. We said that's what inverses do. Solve for y, and once we get it solved for y, that's our inverse function. Okay, so let's look at, I'm going to do 3 of these. Okay. Alright, so just a second. Okay, sorry about that. The dog's going crazy upstairs. I hope you can't hear him. Okay, we want to find the inverse of f of x equals 3x minus 2. Okay. So let's go through the steps. Step 1, instead of f of x, I'm going to say y equals 3x minus 2. Step 2, I'm going to switch x and y, so I'm going to say x equals 3y minus 2. Step 3 is usually where most of the work comes in, so now we need to solve for y. So I'm going to add 2 to both sides to get x plus 2 equals 3y. And then I'm going to divide both sides by 3. And that cancels that, so this gives me, I'm just flipping it around, gives me y equals x plus 2 over 3. So this thing is my inverse. So if I want to write it down that way, f inverse of x is x plus 2 over 3. Okay, and you can kind of tell these are backward from each other, right? Because on the first one, we multiply by 3 and then subtract 2. And on the inverse, we add 2 and then divide by 3, right? So you can tell they kind of do the opposite. All right, let's do another one. That one was pretty simple. We want to find the inverse. We're going to start with f of x equals x to the 5th minus 3 divided by 2. Okay. So step 1, I'm going to switch f of x to y. Step 2, I'm going to switch x and y, so x equals, it was x to the 5th, so now it's going to be y to the 5th minus 3 over 2. Okay. Now we want to solve for y. Okay. So here I'm dividing both sides by 2, so I'm going to multiply both sides by 2. Okay, that'll cancel out, so 2x will be y to the 5th minus 3. Right, the 2 on top, 2 on the bottom cancels out. Then I'm going to add 3 to both sides, so 2x plus 3 equals y to the 5th. But I don't want y to the 5th, I just want y. Let me make a little room here. So what can I do to get rid of that y to the 5th? I can take the 5th root of both sides. Okay. So that'll give me the 5th root of y to the 5th is y. And that equals the 5th root of 2x plus 3. And then for step 4, we could say f inverse of x equals the 5th root of 2x plus 3. Or another way you could write this, instead of 5th root, you could write 2x plus 3 to the 1/5 power. That's the way the textbook usually does it, but either one's okay. Alright, let's do one more. Not number 5. Do one more. Find the inverse. Okay, so this time we're starting with f of x equals 2 plus the cube root of x. X, not 3. Okay. So step 1, I'm going to change f of x to y. Then I get 2 plus the cube root of x. I'm going to switch x and y on step 2, so x equals 2 plus the cube root of y. And then I want to get y by itself. I want to solve for y, so I'm going to subtract 2 from both sides. Leaves me with the cube root of y by itself on one side. And now we need to cancel out the cube root, the third root. So what can we do there? We can raise both sides to the what power? Third power. That way this cube root and third power cancel each other out. So now I have y equals x minus 2 cubed, or to the third power. Oh, and I forgot to number this step. Okay, and then the last step, step number 4. Instead of y, we call it f inverse of x. Is x minus 2 to the third power. Okay. Hope this section doesn't give you too much trouble. Let me know if you have questions, though.